Next question that you're having is, so let us try to see how to solve this one. These trigonometric functions are in the denominator. You have the trigonometric function in the numerator. Because in the denominator you are having sine and cos, numerator also you have to get in terms of sine and cos. How can you make this one in terms of sine and cos? Cos square of x plus sine square of x. So can I replace this one by cos square of x plus sine square of x, or sine square of x plus cos square of x? Can write that one in that form. So I was asking you one question. So we'll get an idea that one has to be replaced by sine square of x plus cos square of x in the examination. So now further, what has to be done is you have to just separate it. The first term you can divide that by denominator. The second term also you can divide by the denominator and try to simplify it. Let us try to see how to divide it. So I'm just dividing it. So integral of, I'm dividing sine square of x divided by sine x into cos cube of x into dx. Separated the integral, plus again separated for the second one, that is cos square of x divided by sine of x into cos cube of x into dx is equals to, now you can just cancel out one sine, and out of this sine square one sine will get cancelled. Here cos square will cancel out with cos cube, one cos will be left out there, right? So if you try to rewrite this one, I'll be getting integral of, this is sine. Can I rewrite this as sine of x divided by, can I write this cos cube as cos x into cos square of x? Can write in this way. Cos x is written as cos x into cos square of x plus integral of, here cos square is gone and you're left out with by sine of x into cos of x into dx. Or further, we can rewrite this as integral of, I'll try to group this sine x by cos x. This sin x by cos x gives us tan x, gives us secant square of x into dx. Tan x, because both are in the denominator only. Sin is also in the denominator, cos is also in the denominator. So now the question is how to simplify that one. Both are in the denominator itself. So can I again convert that in the form of some sine or some cos value? So here you're getting cos square in the denominator. So is it possible to get cos square in the denominator? You have to get cos square in the denominator so that once again you will get the same value. Okay, I'll do one thing here. In the denominator, multiply and divide by cos x. Let us see what happens. What I'm doing, I'm dividing by cos. So I'm dividing by cos, multiplying by cos. Divide and multiply by cos. And this cos x, which is already there in the denominator, will remain as it is. Or now if I try to group this one, sine by cos will give us tan, because here I have grouped sine by cos tan. Where sine is already there, how to get tan? So you have to get cos x in the denominator. So how to get cos x in the denominator? The only way is multiply and divide by cos. So keep that in idea, multiply and divide by cos. Or further, if you try to simplify this one, you'll be getting integral of, this is tan of x as it is, then secant of x as it is, yes, it is integral of 1 by, that is 1 by sine by cos will give you tan x, give us secant square of x into dx. So now you can integrate this one. You can use substitution method, but the value of tan of x, both the case, I'll be taking it as t only. Integration of tan will give us secant square. Secant square of x into dx will give us dt. So in both the cases, you're having secant square. So just plug in. Integration of tan will give you t, secant square of x into dx will give you dt, plus integral of 1 by tan x will give us t, secant square of x into dx dt. Now integrate. Is integral of t, so it becomes integral of integration of x dx. Integration of x is what? X square by 2 plus the constant of integration t. 2. What about integral of 1 by x into dx? 1 by x into dx is log of mod x plus the constant of integration c. Therefore, you can write mod log of mod t plus the constant of integration c. But what is the value of t I have taken? Tan. So therefore, you can write tan square of x divided by 2 plus you are having log of mod. T value is what? T value is tan x plus constant of integration c. So that gives us the required solution.